So I wanted to show how, again, we can create one whole that shows two different denominators in the pattern blocks. So if you think about our two fractions, right? The example was a fourth and a sixth, and I just wanted to show how I got these. And so as before, right, you can name any fraction and iterate it, right? Or any shape and iterate it to create the whole. So we could have called the hexagon, right, 1/4. We could have called the trapezoid 1/4. We could have called the rhombus from 1/4 and the green triangle, right? We haven't really used the purple, the orange, or this tan one, because the other four have these relationships. We want to, when we're thinking about creating one whole with two denominators, we want to be sure that the piece that we choose as either one can be broken up into the other, right? 1/4 needs to be able to be divided into 6 equal pieces. And that's really important because, right, 1/4 divided by 6, or 1/6 of 1/4, right, is going to be our 1/24th, right? This common denominator. And so this gives us the rationale for where common denominators come from. We need to be able to show both in this one whole, both of these fractions, both sixths and fourths. And in this case, right, with 24, we can show other fractions besides just sixths and fourths. We could also have chosen 12 as the lowest common denominator, right, or the least common multiple between 4 and 6, but you don't have to. So so again, we want to create 1/4 that can be cut into 6 equal pieces. We also want to show 1/6 that can be cut into 4 equal pieces. So that's not while we can see that, yes, right, we have 4 green triangles here, is how we can think about this 1/6 shape. But if you're looking at this whole, so you do this step first, right? We have 1/4 is 1 hexagon. So we do 4 hexagons as the whole. Now you might be thinking, well, how in the world do I know how to find a sixth? You can convert to common denominators, right? 1/4 would be 6/24ths. 1/6 would be 4/24ths, and put all of the green ones together. That's fine. But again, if you're thinking like, well, my learners aren't going to have that that knowledge yet. We want to use these models to develop that knowledge and to have it make sense. Well, what I want you to do is think about, well, how you can think about cutting this whole shape equally into 6 equal parts. And you might be like, I still don't really know how to do that or what that would look like. So we can do is literally divide this up. And so if you see the relationship between, right, clearly 4 isn't divisible by 6, but if I see this relationship of 3 rhombi that fit in each of these hexagons, and so I can see then 3, right, then I will have 3 rhombi in each of the hexagons, means I'm going to have 12 total rhombi. So what I can now see is, well, 2 of these, right, now I can cut 12 into 6 equal pieces, right? We can see that's 1/6. Here's another 6th. Here's another 6th. Here's another 6th here. Another 6th, right? We're looking at the shape and the space that each of these shapes takes up. So here I can see, right, this now whole, right, these 4 hexagons, or the area, the space of 4 hexagons. And now I can see that divided into 6 equal, right, the blue, the orange, the yellow, the green, the purple, and the black, right, 6 equal areas. So then each of these areas, right, 2 of these rhombi together is then 1/6. And then, yeah, you guessed it. How much is 1 rhombus? There we go. Right? 1/12. Right? It's half, right? Half of a sixth. 1/2 of 1/6 is 1/12. Or again, how many of these blue rhombi fit in, right? There were 12 of them that fit in this hole